Okay, so let's look at some logarithmic equations. So the first one, we have log base 2 of 7x minus 4 is equal to log base 2 of 2x plus 1. So like the exponential equations, when we have the same base, we can use that to set what's inside equal to each other. So log base 2 of 7x minus 4 equal to log base 2, 2x plus 1, gives us that 7x minus 4 is equal to 2x plus 1. And we need to solve for x. So subtracting 2x from both sides, so 7 minus 2 would give us 5x. And then adding 4. 1 plus 4 is 5. Well, what do we get that x is equal to? Divided by 5, we get that x is equal to 1. Okay? Now we're not done. That seems really simple. We're not done yet. We always have to check that the values we get for x, when we plug them back into the parentheses, we don't end up with a negative in the parentheses. Why? Just like before in the last problem, if we get a negative in the parentheses, it's undefined. It's not in the domain of a logarithmic function. So 1 times 7 is 7, minus 4 is 3. Whew, we're good with that one. Okay, what about the next one? 1 times 2 is 2, plus 1 is 3. Good. So both of those are positive numbers, so we're left with x equal to 1. Okay, I'm going to let you all do 2 on your own, but I'll show you number 3. So number 3 says the ln of x plus the ln of x minus 3 is equal to the ln of 5x minus 7. So here we all have the same base on our logs, but we have 3 separate ones. So let's combine this right side into one single log. So since they're being added together, we can use the product property, which would say that ln of x times x minus 3 is equivalent to ln of x plus ln of x minus 3. And then the other side stays the same. We didn't change it at all. Okay, now we have 2 logs set equal to each other that have the same base. So their insides are equal. So x times x minus 3 is going to be equal to 5x minus 7. And we want to solve for x. So first let's distribute. We have x squared minus 3x minus 5x plus 7 is equal to 0. That's an x squared. So we have x squared minus 8x plus 7 is equal to 0. So we can solve this quadratic and we get that x minus 7, x minus 1 is equal to 0, or that x is equal to 7 or 1. Okay, but we have to check, remember? So if we plug in 7, well 7 is positive, 7 minus 3 is also positive, 5 times 7 minus 7 is also positive. So 7 works. Okay, what about 1? We plug in 1. 1's positive, we're good. But 1 minus 3 is equal to negative 2, which is not greater than 0. So we have to throw out 1 and we're only left with x equal to 7. As 1 makes our logs undefined. Okay, the next type of problems we're going to look at are solving logarithmic equations, and we're going to use our exponential form, so our ability to go back and forth between the two. I'm going to let you read these 5 steps on your own, and then I'm just going to model it in a few examples in the next video.